Hello, everyone, and welcome to today's webinar on direct Connect KVM versus KVM or IP. My name is Bo, and I'm a product manager at Convena. Before we start with the actual topic, let me just quickly run through some housekeeping items. Throughout the webinar, you will all be muted to ensure a smooth presentation. Feel free to put your questions in the chat box on the right-hand side of the screen, and we will read out the questions to the panelist team at the end of the presentation. We are also recording this webinar. The recording will be shared with you at the beginning of next week. Now I'll pass over the word to UK and Nordic Sales Director Bridget Hayes for a few comments on the cooperation between Convena and Blackbox. All yours, Bridget.
Thank you very much, Bo. Just from Blackbox side, thank you to everybody that's joined the seminar, webinar. I'm in no doubt that you will find it productive, and we're very excited about the opportunity to be able to engage with Convena's valued partners. Just overall is that we've identified Convena as our chosen distribution partner in Denmark, and this partnership started at the end of 2018. One of the main reasons that we went with Convena is the fact that Convena's got a very, very good stock holding. They've got a great warehouse so we can put stock in to be able to deliver the stock to our resellers and to our customers in Denmark. They've got a great sales team. We do a lot of joint marketing activities with the Convena team, such as joint campaigns. So any resellers that are on this call, if you do want to do some marketing off the back of these KVM webinars that we've been hosting, please reach out to your Convena team and we can start to see how we can help and support you. So with that, I'd like to hand this over to Brian. Brian is our lead application engineer. Brian's based in the UK, and he's going to be able to bring you up to speed with our KVM portfolio. So without further ado, Brian, I'm going to hand this over to you. And thank you once again to Convena and Convena's resellers for opening this platform up to Blackbox. Thank you very much.
Good morning, ladies and gentlemen. Today we're here to have a look at Direct Connect KVM versus KVM over IP. And we're going to start off by just adjusting our common terminology so that we will understand some of the common terms which are used within the KVM environment and are used in a lot of different ways to represent a lot of different things, but we're going to get that straight from the word go. And then we're going to have a look at the evolution of the control rooms. We'll move on to the KVM technology control rooms. Then we need to look at the benefits of Direct Connect and the benefits of KVM over IP. They both have particular unique benefits, and depending upon customer application, may decide that Direct Connect or KVM over IP is the better solution for you guys. And then we're going to just briefly have a look at a few use cases. So, I'm going to start off with the common terminology. Transmitters, which we short code down to a TX when we're doing on drawings. Basically, all these are source devices. So you've got transmitters or TXs, CPUs, PC computers, servers, playout systems, players, digital signage players, all these, as far as we are concerned within this presentation and within KVM overall, are source devices. So they are the devices that are sending out video and receiving keyboard and mouse instructions. In some instances, they will also be sending out audio, and they may be looking at inputs from other such human-machine interfaces, which brings us neatly on to the destinations. So receivers are short-coded to RX, especially on technical drawings. We call the desk that the user sits at the console, and this is often short-formed to CON. This destination can also be called the user station, the desk position, screen, monitor, remote, or human-machine interface. So all of these terms are often used within the industry interchangeably, but basically we divide everything down into sources and destinations. Sources are sending out video, destinations are receiving video. So we're going to quickly have a look at the evolution of the control room. We're not going to go back to the 1800s or anything silly, but if we go back sort of 10 years ago, 20 years ago, then pretty much everything within the control room was analog based. So there were CRT monitors, the old cathode ray tube monitors. These would be generally mounted into a load of steel work within the control room, very big beasts. You wouldn't really see a lot of difference in some ways because the big box of the CRT was sort of sunk into the walls, but unlike the modern flat screens of today, they took up a lot of space behind the wall. And probably the most prevalent way of noticing that it's a CRT is the fact that the screen is not flat, it was curved. The control room tended to be quite a bespoke environment, and each one was custom made for a particular customer requirement. So desk positions were uniquely put together. There was a lot of analog control systems on the desk, lots of switches and knobs for switching on and off various devices. Very little standardization throughout the room. Only very basic networking was employed, and next to no network security. Networks were not really as big as they are these days. Didn't really have the number of hackers that we do these days. So networks were not particularly well protected. And what you'd often find is there'd be one or two devices coming into the control room that were coming in via a network. But a lot of the other results that were being displayed were coming in from very old interfaces, RS-232 or RS-449, going through some kind of bespoke processing to produce an image on the screen. And you can see from the picture on the left, it's quite a non-ergonomic environment. Got all these switches on the desks and knobs and buttons, and it's all very hands-on and manual, not the way that things tend to be done today. And it was a very static output. So you only had typically one device per screen. If you'd got 20 devices, you needed 20 screens. If you've got 200 devices, you needed a very large video wall full of CRT monitors to be able to display everything. So roll forward 20 years, and things have become a lot more integrated. It's a multi-human machine interface, and we often support bring your own device in the office. There's a lot of live monitoring of feeds going on. That's live statistics, live video, all coming through into the room. Things have moved from analog to digital communications, and we have standardized pretty much everything. Everything's networked. Everything's on an IP system, and therefore has the potential of being hacked. So there is now cybersecurity everywhere. There's ergonomic regulations that have been brought into place to make user desks a more comfortable place to work. So we're no longer looking at these great big mammoth machine rooms with desks with lots of large switches and knobs and buttons. We're looking at discrete desks, keyboard, mouse, telephone, and a collection of monitors per user, and then typically an active video wall or several video walls within the room to get up-to-date information to be displayed, so that everybody in the room has got a common understanding of what the current situation is. So control rooms have changed a huge amount within the last 20 years. Now, the original intentions and basic capabilities of the rooms were very much one-to-one basis, one computer to one screen. Typically, you may even have one user per device managing that device. These days, we've virtualized a lot of the communication. So rather than having 200 computers, we might have 20 computers, but each running 10 different jobs through virtualization. So there's a lot more resource sharing, which makes much more effective use of the processing power that's available. So in the old days, we'd look at trying to back rack some of the equipment. Now, back racking, hopefully for some of you, you'll remember from our previous session, it's just the act of taking the server or the computer out of the room that you're working in and putting it into a nice, clean, clear data center using KVM extension to bring the keyboard, monitor, mouse, or whatever your interactive devices were to your desktop. This helped to reduce noise, kept the room a little bit more comfortable. Today, what we're having to do is connect a lot of different infrastructures and systems together and bring them into single points of visibility. And one of the easiest ways to give customers multiple visibility is to provide a KVM solution. And we also are able to offer, alongside all the other features with the data center, fail-safes and redundancy features, so that if any one device were to fail, it doesn't really make any difference to the operation of the control room. There is a redundant station available or a redundant computer system that can quickly be either manually switched or more typically will automatically switch over. So this helps improve the operator and administrator efficiency. So we may have less operators within the control room, but able to do a lot more than they could previously. So what we offer these people is the chance to extend, switch, share, and control all of their systems across one or multiple sites, brought in together into an easy-to-manage workstation. So where does this leave us heading? Well, these days we tend to focus on improving the user friendliness at the desktop. So allowing people to switch with either hotkeys or touch screens to switch between different systems. We have the possibility of glide and switch, where a user can have multiple screens on their desks using a single mouse, able to switch which screens are connected to which particular servers. You literally glide a mouse across the desktop, switching from screen to screen as if it was just one computer running an extended desktop, when it's actually 4 different screens connected to 4 completely disparate systems. So 4 computers that have nothing to do with each other. But to the user, they appear to be the same, and switching is no longer, we don't even have to use hotkeys or menus or touch screens. You can literally just move the mouse, change systems. We also employ multi-viewers, which allow one screen to display multiple inputs at once. So we can make much better use of the larger screen formats that are available today at fairly cost-effective prices. And we also have individually set user profiles so that user A can access all the systems they need to, and user B can access a completely different set of systems that are appropriate for them. Some of this requires long distance communication, so we may have wide area networking, or more typically fiber extension used at the distributed facilities. Sometimes we're using IP-based extension, sometimes we're using direct connect extension. But in both instances, systems are very scalable and very easy to deploy. So you can build up a matrix switching system very easily and quite cost effectively, giving multiple users multiple access to different devices. We're already in the era of 4K, and 8K has been released. It is possible to go into your local TV shop and buy an 8K television straight off the shelf. Now, this hasn't been taken up for business very much yet. I've not seen any of our customers requesting 8K, but plenty of them are already on 4K solutions. But as we move from 2K to 4K to 8K, this has quite large implications for the bandwidth of a network. 4K solution requires 4 times as much bandwidth as a 2K solution. And an 8K solution is going to require 4 times as much bandwidth as a 4K solution does. So we're beginning to run up with bandwidth exponentially. And no longer, if you're running a 4K system, 1 gig on an IP network really isn't going to cut it. We need to look at 10 gig as being the minimum speed that's required for 4K. So you can see that we're going to be looking at a minimum of 40 gig per connection being available for 8K, unless we get some dramatic improvements in compression techniques. We're also looking at secure KVM, so securing up the switches to ensure that there is no possibility of any unauthorized access or any users being able to get information across the network which they don't have access rights. Virtualization is a massive thing. It obviously can save an awful lot of energy and a lot of processing. Rather than having, say, 100 discrete servers, if you've got 10 large, powerful servers running 10 tasks each, there tends to be a large saving in the power requirements. And what KVM needs to do is ensure that the users have the same amount of access as easily as they do to a single machine when they're connecting to a virtualized machine. And to do this, we may be employing technologies such as RDP or any of the other features that are typically used in virtualized environments. And we're becoming very event-driven. And obviously, the Internet of Things is just adding on to this with even more and more devices that we're putting onto the network that all need managing. Now, just a quick recap on some of the things that we looked at last time. The idea of backracking and why people want to move computers away from the desktops. And first of all, computers generate a lot of heat. Now, if you've got a lot of heat in the office and you're trying to keep the office at a comfortable environment, whether it be a control room or just a standard office, you need to then employ air conditioning to counteract the heat, which is a bit of a waste of energy. Also, the computers generate a lot of noise, and typically the bigger the computer, the more powerful the computer, the more noise it's generating. You've then got the issue of fans sucking in dust and dirt from around them as they try to pass air across the processors to keep them cool. Gradually, this dust and dirt builds up around the fans and slows them down. The airflow becomes less efficient, processors get hotter, and then they fail quicker. You also have the problem of if computers are on the desks, you can have the issue of people fiddling around with them, or maybe the users walked away from their desks and one of their colleagues then comes up to their computer and begins messing around with it. This can be a pain and cause a lot of problems. So what a lot of people do is move the computers to the data center. But then you've got the problems that the computer is obviously somewhere else in the building to where you are. And this can lead to difficulties in sharing devices. So for computers generating a lot of heat, noise, dust and dirt, and being available to be fiddled with, the solution to all of these is to move computers to the data center, where they're locked up, they're kept cool in one large cool room. The noise is contained. The air conditioning units that are used in the data centers filter the air to remove dust and dirt, and the computers are no longer sat on the desktop, so they can't be fiddled with. But now, of course, the computers are somewhere else, so we use KVM extension to provide user access. Now, this can be done on a point-to-point basis, but then there would be no sharing of devices. So that's when we install KVM matrix solutions so that a user has access to all of the servers that they are physically given authorization to access and control. So KVM in control rooms is particularly useful, and it allows people to have a lot of power at their fingertips, a lot of flexibility, and most importantly, to be able to resolve situations quickly and efficiently. So whether it's a blue light control room, a factory control room, or an industrial control room, everyone needs all the information to be available instantly at their fingertips, to be able to switch from server to server seamlessly. So we need to provide users with this matrix system that enables them to be able to connect to anything, and also enables the people looking after the network to be able to control the access to each of these individual devices. We've got the need for high quality video. We need to connect keyboards, mice, sometimes other USB devices such as scanners or cameras, and obviously audio, all the way back from the computers in the data center to the desktop. We need fast switching times. You don't want to be waiting 15 seconds when you switch from one system to another. You need these systems to be available practically instantly. And a lot of our systems will actually switch in around 10 milliseconds, and some of the longer systems in switching take a second. So you can see that it's almost instantaneous. We're back-racking the servers for all the reasons that we've been through, and we're able to provide 24/7 application access. So this keeps the control room fluidly running all the way through every day of every year. We can also provide backup control rooms and have a very quick and easy method for being able to move users into a separate room in case of any emergencies. That separate room could be in a separate building or even on a separate campus, but they still need to have access to everything they had in the main office. But just in case of fire, flood, or all the lines being cut to a particular building, all the mission critical control rooms tend to have a backup. And to give everyone a clear picture as to what's going on, there needs to be support for video walls. So KVM switching. What we typically have are transmitters sat by computers. What these do is they convert the video and the USB and audio if it's required and any other functionality from the computer, and they convert it either into Cat-X cabling or fiber cabling, which then is run into a central switch. So we can see there we've got the Cat-X and fiber matrix switch sat in the middle of the network, the logical middle of the network. It may be that you put the switch in the data center. That tends to be the most common place to put it, so that the distance from the transmitters to the switch, whilst they can be very long, they're typically quite short. Then, using the same Cat-X or fiber system, we run out to the receivers. Now, the receivers sit within the control room, and it's into these that all the keyboards, monitors, mice, headsets, speakers, scanning devices and cameras are actually plugged in. So you've still got all the peripherals that you need around you sat at your desktop, but that noisy hot computer is now somewhere else in the building or across the campus. But a user sat at any PC, if they've got authorization, can connect to any of the servers that are provided. A quick look at video walls. So typically they were fixed board systems or back projection systems in the old days to provide larger displays, and sometimes they were just simple LED dot matrix information boards that would just provide statistics for people in the room. Looking back on the old technology, it was very discreet. So you'd have one computer connected to one screen on a video wall. So as many screens would equate to the number of computers you've got. If you've got 16 computers, in the old days you'd need 16 screens, and each computer would take up one screen each. There are different types of screens, which we'll get onto shortly, and there are different ways in which you can use video walls now, which allow you to make much better use of the video space. They get used in an awful lot of different applications, whether it be transport, industrial, manufacturing, public safety, blue light, broadcast, whatever it may be. Video walls become probably the easiest and most useful way of passing a vast amount of information through to everybody in the control room. And certainly within the blue light environment, everybody in the room needs to have a common understanding of the situation at that moment, with all the latest video feeds and statistics, telephone information on their desktop at their fingertips. But for everyone to see the same thing, a video wall is absolutely perfect. It allows everyone to collaborate much better and can be used to respond to events in a much quicker way. So typically, multiple operators need to monitor and control lots of different applications, whether it be live stream video, live stream audio feeds, mapping information, GPS information, whatever it is, everybody needs access to all of this. So all of these different applications end up being merged onto the one central video wall. We can provide ad hoc secure guest access as well, because sometimes important guests come in, or sometimes you may need to draft in some specialists for a particular incident. Yet again, giving them access to the video wall allows everyone to be able to communicate in a much more coherent fashion. And we're looking now, a lot of the requirements, we've probably moved up to about 50-50 from 2K to 4K screens being used in video walls. So we're entering a tipping point where 4K is going to become the dominant technology. And there are certainly advantages to using 4K within the room. Larger format displays can be used to display much finer information, which is certainly great when you're looking at mapping or GPS tools. We're bringing in mobile content as well. Emergency services are able to stream in video from the public's phones that are actually on site at a particular incident. So we're actually finding a use for, if you like, this habit of people taking selfies when something bad happens and that they film the incident. The emergency services can now get onto these mobile phones with the user's permissions and actually have more of an understanding of how an incident is progressing and what's happening at that particular moment. And of course, they're always designed to be up 24/7. So looking at the three different types of video walls, the most basic on the left is the monitor wall. So these are individual pieces of content to individual screens and nothing but. If you then look at a basic video wall, what you're looking is being able to utilize more screens to show a single piece of content. So you can begin to spread single display over 4, 6, 8, 9 monitors to give a much clearer, larger view. But you tend to be limited by the screen boundaries. So if you allocate a 2x2 display to one particular input, that's going to be the boundary for that visibility of video. When we look at advanced video walls, we basically have all these screens together and they become a continuous canvas. This allows us to put images across different screens at whatever size and shape we need them. And it allows real-time window movement and resizing, and also adding in features like H.264 and now H.265 video decoding. So you can bring feeds in from CCTV cameras, basically put as many or as few of them onto the video wall as you require. So video walls basically help with operator efficiency. They provide a much better sharing capability, much better content control, and they allow remote operation from different sites. You can be now the other side of the world, the other side of the campus, in a different country, whatever it may be, but remote operation becomes much easier. And this helps improve response times and reduce latency. And with that, we need to ensure that there are adequate security risks that are mitigated. So we manage user access by providing users with a certain amount of access control over each server. And of course, in doing this, typically the bandwidth requirement then increase. So just looking at a typical application for control rooms, we've got some video wall processors coming into a wall recorder. So that's just sitting there recording everything that's displayed. So after an incident, you can play back and analyze what the responses were to particular parts to see if there's any room for improvement. Maybe sending alerts out to digital signage screens dotted around the campus. You've got a series of local sources that are coming into a matrix switch. That's going off into the video encoders, pass across into the video wall processors, and you've got a series of desks with the users sitting at them, and normally some kind of control panel, a touch screen, which basically allows you to adjust which servers are connected onto which parts of which screens. So to make the operators' lives easier, the solutions we provide need to be intuitive. They need to be easy to understand and easy to use, and very easy to switch between the different systems. People within the control rooms have different roles, so they need to have unique profiles. So we need to provide the management as a user-friendly interface that makes it easy to allocate resources to all the individual users. We need to automate the notification of alarms. This makes things much easier. You don't want manual intervention to raise an alarm. You need that to happen automatically, and the intervention to happen as a result of that. We try to eliminate single points of application or CPU failure and provide automatic, intuitive switching to redundant CPUs. And to do this, we employ a few other technologies. one of the ones I've mentioned so far is glide and switch, where we have a single mouse gliding between 4 or even up to 8 screens as if they were one large computer desktop, when in actual fact they're coming from a mixture of sources, running a mixture of operating systems, and not networked together in any way, are completely separate devices. Bringing in glide and switch makes everything come under the control of just one single umbrella and gives the user a much faster response time and reduces latency. Sometimes you need to get more information onto your desktop, but at the same time you want to minimize the amount of what we call desk real estate, which basically means space, by having multiple images onto a single screen. So here we see a picture of a real live environment. We can see on the left-hand wall and on the right-hand wall, we've got some very large video walls. These are typically 4K monitors now, so they're able to go into quite a lot of detail. And then you'll see on the far wall, the camera's facing, there are multiple systems being displayed, and some of them are spread across multiple screens. This allows a much bigger display as to what's going on, but in a fairly cost-effective way. So there's an awful lot of information able to be portrayed to the users instantaneously. Now, we've got all this technology, we've got all these video walls, we've got all these computer systems linked up. The question is, what's the best way of actually connecting them? With a direct connect system, we use the raw infrastructure of a campus or a site, whether that be Cat-X cable or fiber cable or both, and we use that in basically a point-to-point system where you have a transmitter at one end, a switch in the middle, and then a receiver at the other end. Everything's over the Cat-X or fiber cable, but there's no IP protocol involved. So these are bespoke protocols, which may seem a bit counterintuitive when everyone talks about standardization, but there are benefits to it in that direct connect systems tend to offer lower latency, faster response, and a better use of bandwidth than a KVM over IP solution. KVM over IP, we're having to bring in video feeds and encode them into the TCP/IP packet we sent over the network. And because we're having to encode video to a particular standard in a particular way, latency becomes involved straight away. The latency is coming down as KVM over IP improves, but it's something to be aware of. So if we compare the two technologies side by side, Direct Connect can offer faster switching speeds. It always has done. It won't necessarily forever. It may be that within 5 years we can get IP-based systems to switch quicker. But currently we have to bring up an IP link and establish it before any data transfer can take place. Whereas with the Direct Connect system, we don't need to. Direct Connect uses, as I say, the raw infrastructure cabling, and therefore it can drive further than Ethernet can. The typical rules of Ethernet are that a device can be no further than 100 meters away on Cat-X cable, or something like 500 meters away on multimode fiber, or kilometers away on single mode fiber. But most sites are flooded with Cat-X cabling rather than fiber, so you're restricted to 100 meters. But using a Direct Connect system, there is generally no problem running 140, 200, even 300 meters over Cat-X cabling. It can't, however, be externally routed unless we then add in some IP technology. It provides lower latency and also higher frame rates. So the quality of the video tends to be better for lower bandwidth. And we can support USB 2 and including USB 3 devices these days at full speed. So 480 megabits per second for USB 2, 5 gig for USB 3. And typically, these devices are modular in design, so you only pay for the features you need. Because everything's non-IP, it's also non-hackable. Now, compared to an IP-based system, we're looking at typically slower switching speeds. We use the network infrastructure, which means we are limited by the Ethernet restrictions of 96 meters plus 2 plus 2, 90 meters plus 5 plus 5, standards you're adhering to, cabling, so you're always restricted to within 100 meters of each device. However, one of the big advantages is that service can be routed across existing campus or wide area infrastructure. So if you've got an IP path one site to another part, to site B, we can make use of that connection and easily send over IP-based KVM information. There will be a higher latency, and it will be at a lower frame rate typically. But it means that we can use switches, hubs and routers, Ethernet extenders, wireless devices, free space optic devices already employed on a site, pass IP traffic across. We can actually make use of those if we're using IP-based KVM. However, USB support tends to be a bit more difficult. We're using most of the bandwidth for video. So we can support 480 megabits per second if the bandwidth is spare. However, when you start looking at USB 3 speeds of 5 gig, no, we can't support that over an IP-based system. That can only be done currently over Direct Connect. Also with IP-based systems, they tend to be of a fixed port design. So if you find yourself in a situation where you need more ports, have to add in new switches. Because it's IP-based, using the standard TCP/IP packet, it also becomes more possible to hack. So if we look at a simple compact KVM matrix over CAT-X, see on the left-hand side we've got 3 servers. This could be anything up to 300-400 servers. Into each one, we plug in what we call a SAM, Server Access Module. Another way of looking at it would be the transmitter or TX device. That plugs into the source, converts the video and USB of the source device into a CAT-X cable, runs into a central switch. In this instance, we're then using CAT-X cable out to a receiver, which is sat on the desktop, into which plugs the keyboard and mouse. Now, distances here can vary from product to product. Typically, you're looking at 15 meters, between 15 and 300 meters transmit switch, and typically up to 3 switch to the receiver. These are direct connect systems, IP is involved. Then we have something like DKM matrix switch, available with an awful lot of ports. Single switch can support up to 576 ports. You can connect multiple switches together. We can basically connect up to 24 switches together, giving you thousands and thousands of ports. And the switches can then be distributed around the campus. But it's a very similar design. We can be using CAT-X or fiber or a mixture of each. Source devices are plugged into transmitters, and then the receiving devices, i.e. the screens, keyboards and mice, are plugged into the receivers. If we look at a KVM over IP solution, it doesn't look a lot different. So every source device has a transmitter. and every screen has a receiver associated with it. The addition of a controller allows for these systems to be set up and torn down per connection, so that if 3 users want to jump onto the same server and view it at the same time, we don't send out 3 individual streams of video from the transmitter. What we do, using the controller, is we log each of the receiving devices, each of the screens, onto a stream that the transmitter produces. And this reduces network bandwidth down considerably. The extra addition on this diagram is the fact that we're able to support virtualized servers directly. So we can put transmitters onto basically servers that are running in a virtualized environment. But rather than having to log on to the individual server and then log on to the individual virtualized server within it, we can pop the user straight on to the virtualized machine they require. And this is something that you have to use IP for. It's a limitation of Direct Connect. You can't really support virtualization in the same manner. Now, it is possible to join the 2 technologies together. So we can see here on the left-hand side, we've got an Emerald switching system that's actually been set up for Direct Connect use. But next to it on the right-hand side is an IP-based system. This is supporting some virtualized servers and some individual sources and individual user workstations. So we can begin these days, certainly with the release of Emerald, which is the first product in the world that can do this, to be able to connect across both technologies simultaneously. Now, for a lot of customers, they may have already bought a Direct Connect system, and in the future they want to add on some IP-based connectivity. So here we show one of the ways that we can actually solve this. So on the left-hand side, we've got a Direct Connect matrix with its transmitters at the top and its receivers at the bottom. On the right-hand side, we've got an IP-based KVM system, again with the servers at the top and the receivers at the bottom. We take a transmitter from a Direct Connect matrix and plug it into the output of a receiver from the IP. And now users on the Direct Connect site can actually connect to any of the servers on the IP side. If we then connect a receiver on the Direct Connect from a transmitter on the IP, anyone on the Direct Connect side can connect to any server on the IP side, including the virtualized machines. So what we're able to offer now is the ability for any user on a Direct Connect system to actually hop directly onto a virtualized server. And to bring all this together and to give you one single management tool to manage both the Direct Connect and the IP matrix system, we've introduced a management platform which is called Bogzilla. So this basically manages all the connectivity for you and brings up and tears down what we call the multicast streams. Multicast is when multiple users are connecting onto the single feed output of a transmitter. And it saves a lot of bandwidth because it saves the replication of that data to the multiple users. Basically, the data is streamed into the network and then the users hop onto that stream, but the hopping on is controlled by the management platform. So the benefits of this are that it adds IP connectivity to an existing high-performance KVM network that's already been set up and installed years ago. So it gives that kit better longevity. All of a sudden, you can increase its life cycle by several years. We add virtual desktop infrastructure, virtual machine support into what could not support virtualized machines before. So this gives us the ability to become even more flexible and even more scalable very easily and very cost effectively. As I said, we can bring in IP-based management capabilities, and even though it's IP-based, it will be able to manage non-IP-based systems because that's what it's designed to do. So we help preserve the existing user workflows, and in actual fact, most of the time we'll actually improve the existing user workflow because we will give them the ability to connect to beyond what they are currently capable of connecting to, and to bring in a lot more devices under their visibility. So we're going to have a look at some of the use cases. The first one is within the broadcast sector. Now here within broadcast, people have got typically data storage devices, and these are huge amounts of storage held on a network, and we could then acquire this. Individual pieces of content can be brought into a playout system and scheduled for broadcast across the country or across the campus, which is basically the bread and butter of what a broadcaster does. So they have a huge amount of storage with all the content sitting on it, and they bring the storage in via a management platform to what's called a playout system, where it is scheduled to be played out at a particular time. UIs are located throughout the broadcast facility. The user workflow is improved because they're bringing in not just the storage solution, not just the playout system, but also the management systems, and they'll normally have some remote stations that they can check on to ensure that the content is being broadcast out to where it needs to go to correctly. The KVM systems will allow for annotation, review, and approval from desktop. Sometimes content needs to be approved before it's released to ensure at a simple level that there's no spelling mistakes, that the content is true and accurate if it's a news feature, whatever it may be. So the KVM system allows everyone to get involved and be looking at the same information at the same time, and also to actually make decisions and to pass information down the workload as required. And then remote connections can be brought in via wide area networking to a redundant site that could be somewhere else, just in case there's any technical problems, or power outs would be a common example. Main site. Post-production houses. In the old days, all the very large, expensive servers would be within the editing suites that they're being used in, which makes sense. But the machines are particularly big. They take up a lot of space. They require a lot of power. They do produce a huge amount of noise. If they've got storage in them, then you've got an awful lot of disk drives being accessed, because the content that's held within editing studios tends to be very large indeed. Don't certainly want the rooms to become dusty and the fans to slow down. Machines are expensive, so you need to keep those processes cool. And so for all of these reasons, it's nice to get these systems out of the editing suites and turn them into very quiet rooms to allow people to work in a stress-free environment and be very creative. Colorists in particular within editing do like to be left alone to get on with their work, and they do like a silent room, typically a darkened room, and in a lot of instances just sit behind a locked door and get fed pizza under the door to keep them going. Broadcast post-production, editing suites, coloring suites, an absolutely ideal place for KVM solutions. And they tend to connect an awful lot of peripherals on the desktop, very specialized editing tools, Wacom tablets, bespoke desk control systems. But as a result of networking all this together, we often need to restrict access to particular servers, because if one company is working in editing suite 1, rival company is working in editing suite 2, you need to have 100% assurance that the content from one editing suite cannot be seen or accessed from any of the other editing suites. So intellectual property is king within the post-production environment. We have to ensure that we can adhere to all security that we can, and KVM can do this with absolutely no problems at all. ATMs, air traffic management, or virtual towers. So often fiber connections in between the tower and where the servers are stored, which could be downstairs from the tower or even across the campus on the other side of the airport. These are obviously completely mission critical systems, and everything has to be 24/7, 365, total reliability, instantaneous backup in case anything fails, dual redundant systems, often requiring the use of touchscreens to control content with very clear feedback as to what the user is looking at any one time. Can't think you're looking at plane A or information on plane A when in actual fact it's plane B, because mistakes can be hard to rectify. Quite dramatic consequences. So also centralized airport control, although quite frankly that this applies to an awful lot of other types of sites as well, including industrial and factory-based solutions. So you generally have control rooms dotted around airports and factories and control rooms that actually run the building management systems. So CCTV, climate control throughout the whole airport, the whole factory, air filtration systems, all the access to the computer systems for all aspects of the running of the airport. All of this needs to come back to central locations, and there is no way of doing this better than KVM technology. So giving everybody in that control, in that command center, visibility of everything that's going on. I've covered most of this previous slides and what I've been saying, but basically, same's going for factories. It's actually site on Tuesday had a very large factory with some very nasty stuff going on. They use KVM for running all their solutions everywhere, and it basically looks like this photograph. It didn't look a lot different. So they've still got some rather analog control desks with all these big buttons, switches and knobs on. But in addition to that, they've got much more computerized plant control with much better visibility. See there's some cameras that have been set on close-ups of particular parts of machinery. They're getting live feeds from those machinery, not just in the case of video, but also in the case of feedback of the actual solutions of the systems. This could be revolutions per minute, or the amount of light available, or whatever it may be, temperatures, fluid movement, all of this information being brought back to a single desktop. And the user, using their keyboard and mouse, can switch between all this information, so they've got everything at their fingertips. They don't necessarily use massive matrix control systems, but there'll only be a few users dotted around in these particular rooms. They still need matrix switching, these few users, to be able to access all these disparate systems. Public safety, and very much with blue light services with this, so police, fire brigade, ambulance, coast guard. Connecting multiple operators with PCs, Video walls, very much a part of what these guys are doing, giving them a lot of information, a lot of visibility. Maps, map layering information over the top of the maps, GPS information, showing the whereabouts of all of the emergency staff and crew, helping provide fast response times, the ability to connect on to mobile phones that the members of the public have on them, giving them multiple visibility from different angles of a particular event. And the more information you've got when you're attending an event, better can be at deciding which services need to be where and how you're going to tackle the problem, how you're going to bring about a successful resolution. And very much in this case, reliable, fast switching times become absolutely critical. So we can see there's a user there with one keyboard and mouse on her desktop. There's also a keypad on her desk used maybe for switching to some preferred servers for each of the screens. Sitting behind this is the KVM solution, providing centralized management and also ensuring that only users with access to particular systems will be able to see this. So, how can Black Box help? Well, we basically get involved from day one if we can. So we get involved in the assessment of what is required, what's existing, what we can reuse, what needs to be improved upon, the planning of the installation, and then the implementation. We deal with more than 500 control room projects a year. We're very, very used to doing things. We help choose the right products for the customers. We help them understand what the benefits of each are and allow them to make an educated choice as to how they want to move forward and which technologies they want to employ. So with the case of KVM Direct Connect versus KVM over IP, it's very much a case of horses for courses. There is no one technology that's right for everybody, and in quite a few situations we would employ both technologies to get the solution to be what the customer actually needs. So there are benefits of each. Direct Connect tends to offer faster response times, lower latency, higher frame rate on the video, but you can't route it. Now, IP systems, they're beginning to catch up the latency front, but they require much higher bandwidth. But they have the fantastic benefit of being routable across site, across campus, across the world. So we can help you design these solutions with our pre-sales teams. We offer free post-sales technical support to absolutely everybody. And we can also offer optional installation services and individual service level agreements. Now that brings the presentation to a close. I do apologize for running over by a few moments. Here are the contact details for myself, Bo, Casper of Convena. I'd like to thank you very much for your attendance and hand over to the guys of Convena to see if there are any questions that have been raised. Thank you very much.
Thank you, Brian. We do actually have a few questions. One of them is, when would it be a good idea to use secure KVM?
Secure KVM would be typically used in a military or government environment, and the secure KVMs are unique in that they are designed from the ground up to negate the possibility of user A being able to gain access to any of the servers that user B is currently looking at, and vice versa. So rather than a normal KVM switch, which is designed to give everybody access, assuming they have access rights, there can be ways of hacking these devices. There's very specialized equipment around. There's some sort of EMI, RFI handset gun-looking things that you can point at cables and begin to read data off those cables, or point them at switches or KVM boxes, and you can actually begin, not easily, but you can begin to get a picture of actually what's going on. With secure KVM switches, you cannot do this. They are designed ground up to isolate every individual feed. They tend to be more expensive, so they are only employed where they are absolutely required, and that tends to be military and government, so things like the Foreign and Commonwealth Office, the Home Office, some of the larger central police stations may also employ them, but certainly all of the Army, the Navy, the Air Forces, they all use secure KVM switches all the time. So the use is mainly government and military.
Okay, one final question, Brian. Next week's webinar, what is the topic, and what can people expect to learn from it?
That's a very good question. Thank you very much for asking. I think I'm going to have to go back to slide 1, unless we have the ability for Gert to jump online.
I can help you a little.
Can you? Please do.
Yeah. Black box KVM solution update.
Oh, fantastic. Okay. So
what components?
Thank you. Thank you so much. So what we're going to be talking about next time is basically giving everybody a general update on all of the new features that have been recently brought into KVM. And this is including some of our devices that now have glide and switch built in. There's a lot of extra features and benefits that we've been building into our products over the last year. We've got a team of designers based in Ireland that are constantly trying to upgrade the products based on customer feedback and customer requests for extra features. So in next week's session, what we want to go through are some of these features that are being introduced, what the latest steps are within the KVM arena, and how things are going to look moving forward.
Thank you, Brian. And before we wrap up, I would just like to pass the word over to Kasper Magnussen, and thank you. See you next time.
Yeah, hello, this is Kasper from Convena. If you have any questions about this presentation, anything else, please feel free to reach out to me, Bo, or Brian. Blackbox can aid us with all the technical support we need, and you as well. So in case you have some questions that pop up after this presentation, please feel free to reach out for me. And then I would like to thank you all for showing up for this webinar, and I hope to see you all next time.
Thank you all very much indeed. I'm just going to leave our contact details up on the screen for a couple of moments before I close the webinar completely. I'd like to thank you very much for your attendance, and as we said, any questions, just route them straight through to us. Thank you very much. Take care.